Ladies and gentlemen, 2 minutes until the quiz begins. 2 minutes. Ladies and gentlemen, the quiz is now open. Ladies and gentlemen, less than 10 minutes remaining. Less than 10 minutes remaining in the quiz. have approximately 2 minutes remaining. 2 minutes remaining in the quiz. Okay. All right, ladies and gentlemen. I hope that quiz 3 was not too nasty. Okay. Again, these are not easy, and they're never going to be easy. But hopefully, it wasn't too bad, or at least not as bad as you were expecting it might be. We'll go over some of the answers, I think, next time on Wednesday. And looking around, like, I think there was one question that I'm not super excited about. So, like, there's a chance I'll take a look at it tonight, and maybe I'll get some points back for that one. But, yeah. Do your best to keep up with lectures, keep up with discussion. Discussion content is still getting tweaked a little bit. You did not need to know some of the properties of matrices that was brought up in discussion. You won't need to know those for the exam either, by the way. Yeah, we're going to keep tweaking these quizzes, keep tweaking stuff, and hopefully it'll get to a smooth point. If you are keeping up with the assignments, the homeworks, relatively well, then some of these questions, I think, you'll be able to answer using your experience from the homeworks, okay? So that's another thing to check if you are looking to use your notes for this exam, for these quizzes. Go and look at the assignment specs too, okay? Because the assignment specs sometimes bring up interesting API quirks or things that you'll need to do, right? For instance, caching images is something you really want to do, related directly to one of the questions on the quiz. But anyway, okay, I won't say any more because not everyone is 100% finished. So let's go ahead and get rolling, okay? You've absolutely crushed homework 6, okay? Homework 6 was the bane of everyone's existence last year, but we now have a number of people who are getting 100% on at least one platform. And that means getting through the performance tests, and that also means getting through them without hacking the test case, which is something I'll talk about in just a moment. Some spice, some drama from a couple nights ago, I think. We noticed some particularly clever code being used to get some particularly good performance results on some of the test cases. No one got in trouble. In fact, the person who brought this to our attention got some extra credit, so good for you. But the course was adjusted slightly due to the existence of those attempts. Anyway, so I want to talk to you real quick about a cool engine, okay? This is an engine that is famous throughout the galaxy, throughout the industry, okay? For many reasons. It is an engine that has kind of had a very dramatic rise and fall. This is the creation engine, kind of formerly known as Gamebryo. And it is the engine of our favorite developer on campus. This is the engine of Bethesda, okay? And now they're owned by Microsoft. It was initially released in 2011, previously known as Gamebryo. And this is the engine that powered some of the most successful games of the previous generations. And I definitely underlined previous there. This is the engine of Skyrim, okay, the Elder Scrolls Skyrim, a very, very impactful release. A release that is famous for its support of mods in particular. This is the engine that has most recently been used on Starfield, an engine that was used on Fallout 3, and it got a lot of acclaim in that era. Bethesda's game engine was famous for gigantic, large, open worlds, the kind of which in the Xbox 360 era, the PlayStation 3 era, you just didn't really see a whole lot of. This engine could do it on the previous generation, the PS2 era, the GameCube era, the Xbox era, okay? And I want to show you an example of one of the engine's best features. It's supporting of mods. Now, you might have seen this if you came to IGDA not long ago, but I want to show it to you right now. Okay, so how many of you have played Skyrim? How many of you have heard of it? So I really love Skyrim, and I want to show you a scene from that game early on. This just really resonates with me. It's going to make you nostalgic for the time that you put into it. Let's go ahead and watch the intro of the game, because I think it's really cinematic, it's really beautiful, and really exciting. It sets you up for an epic adventure. So let's watch the intro to the game.
As fearless as death, as he was in life.
Next, the door to the back.
Here it is again. Did you hear that?
I said, next prisoner.
To the block prisoner. Nice and easy.
What do you see? It's a
You know, right? Skyrim, right? That's how I remember it. So, a quick joke. I gave a talk at IGA recently on modding and hacking, and this is the video that kind of sets the tone for the entire lecture. The first time I gave that lecture and talked about Thomas the Tank Engine in the Creation Engine was at M Plus Dev conference in Madison, Wisconsin, a small kind of indie, not indie, but a small game development conference. And the guy who made the Skyrim mod was in the crowd. And he came up to talk to me afterward. And he told me, I forget his name, unfortunately, but I still have his email. And he told me that, like, I think it was Mattel or maybe Hasbro, whoever owned Thomas the Tank Engine, like, he received legal threats, okay, for damage to the IP and its reputation. And unfortunately, none of that came to pass. They were kind of empty threats. Yeah, it's impactful stuff. And these days, Thomas the Tank Engine appears everywhere. It's kind of a mascot of the modding community, okay? So the character gets a second life, no longer just a children's TV show character, also a hacker, basically. Okay, so let's keep going here. It is famously good at supporting mods. It did run into some controversy in 2015 when it tried to formalize the mod community a bit too much. They introduced the topic of paid mods, where basically mod creators, I think, would be able to list their mods for sale, and Bethesda would get a cut of that. This was very controversial. I don't know if I fully understand why, but the modding scene has definitely a very kind of free form and kind of hands-off streak to it. And they really, really love the ability to share these easily, okay? But Bethesda put in a lot of work to help people find mods and to support mods and make them possible. The modding system, Creation Kit, Skyrim Creation Kit, it has a kind of Lua-like scripting language known as Papyrus. And I'm kind of salty that they didn't just use Lua. I think previous versions of their engine did just use Lua. But you get a lot of familiar things, okay? You can name your script. You can get some inheritance going on. You can define variables, okay? And you have life cycle events, which we'll be talking about a lot soon, okay? Like on trigger enter, which you might remember from your experience with Unity in the first couple weeks of this course, okay? So you can write logic that will be automatically run by the engine when that actor has some sort of event happen to it. There's a function, for instance, called onDeath, on KO, I think, that will run if your actor gets killed so that your scripts can clean themselves up, okay? Anyway, kind of interesting. Yes, and you can look at some of the tools that they use. You can go and you can mod Skyrim if you want to today, okay? The game is available absolutely every place you could hope to play it. The modding scene is probably going to be healthiest and easiest to get into on Windows, I imagine. The Bethesda game engine, right, Creation Kit or Gamebryo, is famous for supporting open worlds on modest hardware. So a huge game, Morrowind, Elder Scrolls, I think 3, Morrowind, absolutely massive game, was ported successfully to the Xbox, the original Xbox. These game consoles are extremely weak. They're underpowered. That's something you need to know. And I'm not sure if I showed this to you, but they had memory leaks in their game, in their engine, that they couldn't solve. So they were running out of time. They didn't have enough resources to hunt down their memory leaks, but they were able to add a little feature to their engine that solved the problem. It utilized one of the unique features of the Xbox as a game console. So I'm going to show that to you right now. How do you solve a memory leak? Well, let's find out from Todd himself. I heard you just helped Todd out recently, didn't you? What was he asking for? Yeah, he was really salty about the topic of lazy loading. So, anyway. All right. Let's hear from Todd.
Xbox, how are we going to get this to even work? And working with them, there's great tricks that they taught us. My favorite one of Morrowind is you can actually, if you're running low on memory, you can reboot the original Xbox and then the user can't tell. You can throw like a stream up the Morrowind load time, you get a very long load, that's us rebooting the Xbox. Someone said, "Hey, you can do this." Really?
Right? And as funny as it is to just throw up your hands and say, we're not going to solve the memory leaks, we'll simply wait until it becomes too much and then reboot the Xbox, right? That might have been the correct engineering choice given the time and resource constraints they were under for a port like that, okay? Given more time, I'm sure they could have solved it and hunted things down. But sometimes you got to do what you got to do, okay? And what I'll say is that anecdotally, the projects that have the worst outcomes are actually not the ones that are rushed. They're the ones that are given an infinite amount of time. At least in the indie scene, one of the worst things you can do to your project is give it vastly more time than it realistically needs. Then things get introduced that shouldn't be, everything becomes unfocused, things get sloppy, and the game eventually kind of slithers out, and it's just a mess. Anyway, okay, so appears to be uniquely prone to bugs.
So this video is a little different than the usual on my channel. For that reason, I'm going to explain a little bit about it, and I'm also going to introduce myself because I'm feeling that it's going to be watched by some people that don't usually watch the other videos. My name is Joseph Anderson, and I have played Fallout 76 for almost 100 hours. I am a games critic, sort of a streamer, and I played 76 for that much in order to do a video on it that has since been released. This video is all about cataloging all of the glitches that I encountered while playing the game. And while that's probably been overdone at this point, I thought it might be important to have a video that is just from one perspective, one person's journey with the game, and all of the glitches and problems that they encountered just as one playthrough that was, like I said, almost 100 hours. The clip that's playing right now is one of the few times that loading into the game took 2 to 3 times longer than it usually did. And what's special about this one is that this is after this patch that went into the game at the time of recording. It is February 5th right now when I'm recording this, and not only did it have a problem with taking too long, it also did this that's on the screen at the moment. It failed to load for the first time. It also shows weird psychedelic background that is unrelated to the load screen. You'll see in a second when it does finally finish loading that this is what is meant to be on screen after loading is finished. And for whatever reason, I tried to load it and it messed up. And yeah, there you go. This is what it's supposed to do. The lighting also changes in a second here, which I thought was good, but you're just looking at the game, so that's how it is. Yeah, so this video is going to be going through all the videos right now. It's probably unnecessary, but I think it's important to have that there as a proof of how bad the game was and how poorly it was put together. And we're going to start with the duplicating camp glitch. So as you play the game, you will move your camp around the world map and make a base that is mobile. You'll have graphic stations like this one that fails to load for some reason in the menu, and you'll also have containers. You can see like, oh, there you go. Sure, one screen after all. Containers in the background, you can store stuff in. Containers are all the same inventory, so it doesn't matter how many you put down. They're just decorative. One container will link to the whole thing. You can store stuff in the camp box directly. So what you're going to see here is that right now it's a normal camp. This is about the second camp down. As you can see, or you saw just a second ago, there were 2 camping stations there, 2 fires there. And the reason why there are 2 is that every single time I moved my camp, everything that I built would duplicate itself. I hadn't realized that yet. I just misremembered and thought I had built 2 campfires, and I hadn't realized that yet. My idea was looking for sledge, and I hit this robot, this is Ultron, and so far, I won't look first, it's okay. The other Ultron macros, and I will be worried, but oh, here's another job to that T time is started, it's not I'm nowhere near that, I'm miles and miles away, and that triggered some reasons. Anyway, so I'm attacking this Ultron, and now my attacks aren't doing damage, the servers are crap now, we can still do somehow. The reason that is that you can start to see the background right now, is beginning, these Mr. Andys are appearing because every single robot has not heard on to me, because I attacked this Ultron, for some reason it really, the loot table disappears from that robot before I have a chance to loot it. This will be a theme here, as you can see, as their corpses will vanish, and you can't loot them, next speed for some reason. So every robot has aggroed onto me, and it's coming, and that's why the servers are starting to struggle, because it is just right along. I have a theory that...
Okay, you can watch this. It is 3 hours long if you want to. The interesting question for us here may be, is this a bug in the game, as in the gameplay logic, or is this a bug in the underlying engine? Is there something in this engine that makes it uniquely prone to being having bugs written in its gameplay logic? Right? One of your missions as an engine designer is to try and create abstractions and APIs that make it hard to write a bug. Okay? Now, this is impossible to completely get rid of, because what is a bug? Well, if your game designer is writing Lua logic, gameplay logic, and they don't know what they want, they'll write a bug, right? If they, deal with arrays incorrectly, they'll write a bug. But the way you design your APIs can make it more or less likely that your game designer will make a mistake. If you do things in an unintuitive way, if you have strange rules, okay, if your engine has requirements, okay, that are not stated, assumptions that you make, then you're setting your users up for failure, and you're making it more likely that they'll create bad, unstable games, which would be bad for you as the underlying engine. It's 2025. What is the reputation of Bethesda Game Studios' main engine? Yes, Starfield did poorly. It was regarded as being behind the times, not super well done, and still unstable. And it's a big problem, okay? Unfortunately, the reputation of this engine now might force Bethesda to either rebrand it or to reboot altogether with a new engine, because people are nervous about the next Elder Scrolls game because of the technology it uses. That's not the reputation you want your tech to get, okay? All right. Oh yes, I want to show you something. In the Elder Scrolls Skyrim, when an important character gets killed, we can't just despawn and delete the character. Don't ask me why. So here's what the game does instead. This is the corpse room. Underneath the map, at a very specific location, is a strangely lit room where dead NPCs get placed. Their corpses just get spawned and moved there.
Yes.
And I guess some that are not dead, but that the designers want to get rid of, they get moved to the corpse room. Okay? So why would you do this? Can you think of a reason why Bethesda might do something very unintuitive like this? Possible, but you have to wonder, why can't I just delete them from the world and then respawn them later if I wanted to revive things? What's the point of the corpse room?
Is it to prevent memory leaks?
Possibly memory leaks. Possibly. Certainly possible. I don't know the answer. Yes?
My thought is that because of this, you're technically not deleting any actors. They still exist. They're just in a dead state, which lets you do optimizations that involve the number of actors never changing.
Possibly. Yes. I think that's a really good question or answer. Either it's an optimization where we're going to say, hey, we're never going to get rid of these NPCs. We'll always assume they're there. Thus, we can optimize based on the fact that we know how many NPCs can possibly exist. I think that's a good idea. I don't think it's quite as convincing as this idea. If we delete important NPCs, this creates dangling references throughout our code base, which causes things to get unstable and crash. Right? So it's probably a limitation of the engine and its scripting system that, hey, we actually can't get rid of certain really important NPCs that are plugged into certain systems, because if we delete it, now we've got a bunch of null data everywhere, and the systems can't just fix themselves up. So we have to not get rid of them, or this is how we get rid of them. That's how we keep things stable, okay? And this looks like horrendous tech debt to me. Like, this is not good software. This is not a good solution. It's a good solution if you are literally running out of time to finish Skyrim. But by their 10th edition of Skyrim that they put out, maybe it would be really cool if they kind of fixed this, right? You know, for the next game, so they don't have to do this again. I don't know if they did this again. I would not be surprised if they did. So anyway, that is our Bethesda, everyone's favorite game studio, okay? And I'll keep you up to date with them if they get any headlines at all. Okay, so one more week of Homework 6. A reminder to all of you, Homework 6 was not due today. It might have felt like it was due today, the way that a lot of you were rushing toward 100%. Like, well done, by the way. You've all earned yourself a free week by doing that. So Homework 6 is still around for another week. If you've not caught up, if you've not begun Homework 6, that's not great. But if you haven't started Homework 6, you now have proof that it can be done in 1 week, okay? Hopefully without a ton of stress. You'd have to ask the people who've gotten and finished Homework 6 how stressed they feel right now. But you should all know that Homework 6 has that additional week, and we hope you'll use it. Reminder, you don't have to get 100% on these. If you're just dumping hours in the performance test cases, take a break. You don't really need them. You can even get an A without them. Remember, there's extra credit in this course, okay, coming at the end of the semester. Another thing to note is that we have spring break coming up, a free week. Okay, don't worry about it. Homework 7 will get 2 full weeks, even if you skip that third spring break week in the middle, okay? So we assume, and the assignment is designed such that you don't need it, okay? Homework 7 is not the world's hardest homework, especially once you get rolling. The hardest part is that you're going to have to learn a little bit of Lua, and you are going to have to get a feel for component architecture. Okay, if you have experience in Unity or Unreal Engine, you know all about components, and you are probably, hopefully a fan. You'll be implementing that architecture in Homework 7. You'll have 2 weeks to do it. The performance test cases, I don't think, does it have them? I can't remember. But it moves very fast. I think you'll really enjoy Homework 7. Everyone loved it last year, and things have only gotten nicer and more pleasant in the course since then. So a quick announcement that is of interest, kind of a spicier announcement, was that there's a new policy related to performance test case hacking on Homework 6. This is particularly relevant to the performance test cases on Homework 6. It's not as scary as this is going to sound, but if you look on the Homework 6 assignment spec, in the performance test case suite, suite 6, you'll see this note now, okay? So basically, what you can do on Homework 6 is you can poke and prod the test cases to figure out how they work, and you can kind of progressively choose to ignore certain actors completely to make things go faster. Now, this only works because you don't have a human in there doing things, right? The test case doesn't randomly choose what's going to do that run. It only does the same thing over and over, okay? So theoretically, there are some optimizations you could apply here that will break in just about any other scenario, okay? In other words, there are optimizations you can make that are specific to the test case, okay? But if someone were to take your engine now and make a game out of it, it would shatter. And correctness would very obviously be lost very quickly, okay? And so we refer to this as test case hacking, and this is not getting you any additional knowledge. This is not vetting your understanding of the optimization process. This is just you kind of cheesing the test case, okay? That's not something we want in the course we want to let you know that we'll be looking for it. We're going to be scanning through it. And this is not a change I wanted to make. We upgraded the test cases to make this harder to cheese, but it's unfortunately, due to the nature of this assignment, it's pretty trivial to cheese this to the moon and back. It's a cat and mouse game that I'm not interested in participating in. I've got other fish to fry. And so here is your policy. The pain here is that the entire course staff now at the end of the semester has to read through every one of your homework 6 test case suites or your code bases. Not super fun, but we know exactly where to look. Okay, and we have your commits. We only need to judge one commit, your best one, so that's what's going to happen. Okay, we're not going to be happy at all if we see that you are doing these hacks, and I think this is the only homework that's going to be especially vulnerable to these hacks, because on homework 7, 8, and 9, basically everything will be checking for performance reasons. It's going to be in your main window and seen by the test case as it walks past. So, just know that, a bit unpleasant that we had to do this, but it's not the end of the world. And, for the students who raised this, right, you did nothing wrong. You stayed to the spec. There was no policy against this. So thanks for the pen testing. And those students also got some extra credit as well for bringing up this case and improving the course. So anyway, you had a question?
You answered it.
Oh, I answered it. Okay. What was the question?
How are you gonna know if someone's doing this? Because you're just gonna look through every single.
It's very obvious.
Yeah, well, I don't know if there was like a.
Basically the most obvious form of this hack is, hey, there are actors thousands of units away from my player. Don't do anything with them. Because chances are our test case won't get close to them, and chances are they won't be moving fast enough to get over to us. If they are moving fast, then just ignore the ones that are moving slow, right? And so you can escalate this as long as you want, and it gets more and more annoying to deal with. You can see how this doesn't generalize at all to an engine that would be useful, right? Yes?
Yeah, my thought was that I do know that there are a lot of actual game engines that will optimize based on, an actor isn't visible on the screen. Don't update its position. Start updating it when it enters the screen.
Yes, there are certain games that have logic related to that, especially like old school games, like NES games. That breaks the optimization we want you to do on this particular assignment. So anyway, so keep that in mind, and you can always reach out if you're worried that an optimization might get you caught in our filter at the end of the semester, okay? All right, so what I want to do, this is maybe something that will make some of you groan. Hopefully, if you've seen this topic before, I can spice it up a little bit for you. But we now have a week of Homework 6, and I don't have a whole lot more to say to you about Homework 6's content. So it is time to start enveloping you with the topics of Homework 7, okay? But I want to do it slowly. I want to warm you up to it because conceptually, Homework 7 is the hardest homework in the course, okay? But if you understand how game logic is externalized, then it will be possibly one of the easier homeworks in the course, okay? And I want this to be easy for you because you know things, because you have the knowledge, okay? All right, so let's go ahead and do that. I'd like to show you one of my favorite games, okay? How many of you have seen this lecture before? Okay, not all of you. Actually, it's less than half. That's amazing. I thought all of you would raise your hand because this lecture is in every course that I run. Anyway, Scribblenauts. I'm in a nice farm. I need someone to say a word, and we're going to bring that word to life. Give me a noun. Someone give me a noun. Yes? Giraffe. I got it. Don't laugh. Okay. There we go. Oh. Can I ride it? Nice. I can ride the giraffe. Okay. I need something else. Yes. Gremlin. That's like IP, I think maybe. Oh. Okay. Toaster. How about a big toaster?
How about a sentient toaster?
I want a normal toaster, then we'll try a big sentient toaster. I want to just compare it for comparison's sake. Here's your toaster. Here's your large sentient toaster. This is going to give it AI when it wouldn't have any before. Oh my god. It's fighting! Go, go, go! No! Oh, it stole the toast, too. This is brutal. This is the worst ending, for sure. Yeah, that was surprising. I'd never tried that before. But basically, the AI, the basic AI component got slapped onto the toaster, whereas the toaster usually doesn't have that. Okay, what else we got? Yes?
Effervescent immortal snail.
Immortal snail. Is this how we're going to defeat the gremlin?
Effervescent immortal snail.
Effervescent?
Effervescent.
What is? How do I spell that? What does that even mean?
Let's do the immortal EFF. ER. DESCENT.
What does it mean?
I have no idea.
Stunning, incredible, ethereal.
Maybe it'll be shiny. Does that look stunning to you?
It's so
Snail,
Oh my god.
Oh,
but is it immortal?
shiny snail? That one's shiny. Nice.
Yeah, but it's immortal.
You must fight. Okay. Oh no! One hit KO. We have to deal with this. We need Cthulhu. Now we have to deal with Cthulhu. I need a way to set it off, so I'm gonna need a bazooka. But I want this one to be a...
Wielded by a snail.
Oh. Okay, hey, can I shoot you? No, I need to shoot this.
Who is still alive? Oh my god.
Oh, alright.
Yeah.
Okay, hold on. We need to defeat him. Clean this up. Then we can move on. Okay. What? How do we do this? How do we defeat him?
Cthulhu killing gun.
What gun?
Cthulhu killing gun.
No, I don't think that'll work.
It's a gun that specifically kills
So,
Cthulhus.
I want to point out a couple things. We can create a noun, which is amazing. But one innovation of this game in particular was that I believe it introduced the adjective system. So you can create a noun, and then you can put as many adjectives onto it as possible. And doesn't that sound kind of familiar to something else, right? Yes?
Can we not just add the adjective of mortal?
Immortal?
No, just normal mortal. It's like, okay, that thing's basically...
Probably wouldn't do much.
Or just
Okay.
normal.
I want a... gosh. What do I want? I want a dancing... No. Oh, it's not an adjective. Can I do with bazooka? No. Dancing combat snail. What? Dancing? Oh my gosh.
Aggressive.
It's dancing. Oh my god. That's super cute. Okay, enough of this. I'm done with this. Gotta take care of this ourselves. Oh my god, 2 tanks. This is brutal. I need something. I need something a bit more hardcore. I need a mech suit. No, I need a. I need a. Okay. No, he's coming. Phil. This is not looking good, people. Bad ending. Bad ending. All right. Okay, that's enough. We do gotta do some stuff.
In the original Scribblenauts, if you made a portal that would spawn one of several, like Lovecraftian monsters.
Oh, really? That's awesome. Okay, so even if you've seen this before, I hope you'll enjoy the reminder, okay? Because composition really is an important part of game logic, okay? Composition is how you find game logic represented across many different engines in industry, in academia, anywhere. Unity, Unreal, Godot, in our engines as well, okay? This is the composition pattern, and this is why it matters, okay? Scribblenauts was a very big game. It made a lot of waves for its impressive technical accomplishments. In 2009, it was created by a small team called Fifth Cell and a large publisher named Warner Brothers. Now, Warner Brothers just ponied up the cash and helped with the advertising. They didn't necessarily build too much of it themselves. The idea, the premise of this game is that you can create any object you want simply by typing its name. And you can provide its name, but also then adjectives to kind of customize it, okay? Now, we mean any object, okay? You can write a professor, and you can get a professor, okay? You can write a jackalope. Does anyone know what that is? Well, if you don't know what that is, Scribblenauts does, okay? Because they really did go down the dictionary and try to get as much of this into the game as possible. And they did a great job, okay? Now, the question for us from an engineering perspective is, how does a smallish team build such a gigantic game with, in such a short amount of time, okay? How does a smallish team even hope to build something of this scale? And what we're going to discover is that the answer is heavy-duty reuse, not just of assets, but of logic, okay? Of the kind of which you're going to be implementing soon, okay? So when you look at engines like Unity, you see a strange pattern where logic is kind of broken up into these little blocks. We call them components, and each component can have its own customizable variables, okay? Its own customization, and you can mix and match these. Now, if you look at Unreal Engine, many of you haven't taken EECS 440, so you haven't done much in Unreal. The UI is very different, but it has the same general philosophy, okay? Unreal Engine just has one gigantic component that combines a bunch of these smaller ones, okay? And you can see a second component on that same actor right there, okay? You can also see that when you click on a component in Unreal, these little configurations change, okay? So you can configure which actors you want to toggle, for instance. Same thing with Unity, it's just a different way to present that UI. In your course this semester, you will be making this kind of component-based system come to life, okay? This probably looks a little bit familiar to you, right? You have what is a scene file right here, and you have a name for your actor. But this is something that you won't really get into until next week. An array, or actually an object, called components, okay? This object is going to contain a bunch of other objects, each object within being its own component that has a key, an ID, that determines in what order the components run. But then each component has a type, and then it has its own variables which get customized and overridden. Some components have no variables that get overridden, and others have quite a few, okay? And so, right, each of these types will map to a Lua file, and each Lua script will have a bunch of things in it. Lifecycle functions, for instance. Functions like onStart or onUpdate. Eventually, you'll create an onDestroy, okay? And variables that can be altered by just writing them in instead of changing the code, okay? So speed, for instance, is being overridden here. In keyboard control, it's not going to be 3 as we see here. It's going to actually be 6 when the game starts, and only for that component, okay? Blah, 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 blah. I just said a lot of stuff, and if you don't understand what I just said, that is okay, all right? Completely okay. So how do we reuse code and assets today? Anyone know? What do you learn in EECS 280 that helps you start to reuse, for instance, classes? Yes. Yes. In EECS 183, you learn about a few methods of logic reuse, right? Functions, for instance, structs. In EECS 280, you learn about classes and you learn about inheritance, and then you use it possibly quite a bit on EECS 281. How many of you are using a lot of inheritance right now in your code base? Anyone? Yeah, the staff solution uses none, actually, which is kind of interesting. It just isn't really necessary. Inheritance is a pretty big deal, okay? It is an extremely popular and very commonly taught method of code reuse. It is usually, one of the first big ones taught when you start getting into classes. Okay, it has wide, ubiquitous support among all the world's most popular languages, except possibly C. Does C support inheritance? I'm sure it's got something like it buried.
No.
No? You're just out of luck?
No, don't use C if you want inheritance.
Yes. It has wide support among most languages, and its usage is basically like this. This is what we call an ISA relationship hierarchy, or an ISA tree. And here's why. A jackalope is a rabbit is an object. A human is an object, a professor is a human, and a student is also a human. A student is not a professor, a rabbit is not a human, okay? And at every level of this class hierarchy, we put logic and variables and different pieces of data that then flow down that tree and get overridden and tweaked by child classes. Okay? This is how we can reuse a bunch of stuff. And in C++, if you want to do inheritance, this is the syntax for that. Okay? You can have a human, for instance, a bunch of public data, for instance, a vector of interests, and a float representing its happiness. A few functions, eat, sleep, talk, and then you might say, well, a professor is a human, but it's going to have an additional bit of functionality called teach. Okay, it's a special human with some special abilities. A student is a human as well, but we're going to override and change the eat and sleep function to do nothing because students don't eat and they don't sleep. Okay, yes?
In C++, is everything an object? Like, I know in Python, like, the base is an object.
Is everything an object?
I mean, like,
What does an object mean? So I think in something like C#, which is kind of a higher level of managed language, like you'll find... So could you say an int is an object? I don't think you typically would.
No,
But-
what I mean is like an object is like a...
Yeah.
What's the word?
So
It's not in C++.
the hierarchy, whatever language you're in, when you start using library files and looking at data types, like especially the chunkier ones, you'll find hierarchies that go way up and become abstract to the point of being very confusing. And I think at the highest levels of like object with a capital O in C#, like I think it's probably providing like some garbage collection functionality or something.
Yeah.
Yeah. Yeah.
From what I know, in a language like C# or Java, you have objects, which is a general, which is the universal superclass to any other class you make. It somehow implicitly inherits from object.
Yeah. That's what I've seen as
C++,
well.
That is not the case. There is no universal
Yeah, that sounds about right. That sounds about right. In C++ syntax, this is what you do, okay, to establish an is a hierarchy, and in many cases, it's not a bad idea, all right? In C#, right, our beloved C#, even when we're doing stuff with components, we will be using a lot of inheritance, okay? You might have an affordance that displays a message to the screen when you interact with something, okay? But that affordance class, you'll discover, is actually inheriting from monobehavior, i.e. component. In Unity, monobehavior is a synonym for component, okay? Anyway, there's a lot of inheritance going on. If you look at Unreal Engine, and most of the classes and blueprints you make in Unreal Engine will derive from something. This affordance class, for instance, has a parent class of actor component. An actor component has its own parent class, and that parent class has its own parent class, right? Big, long ISA inheritance hierarchies are very, very common out there, okay? And for good reason. They're very, very useful. By the way, if you ever go to learn Unreal Engine, here's something that's going to help you. Blueprint, affordance, literally the same thing. Sorry, blueprint, class, okay? Literally the same thing. A blueprint is a class, okay? A class is a blueprint. It's just a different terminology, okay? All right, so anyway, blah, 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 blah. Scenario for you. Congratulations, all of you. You've completed a very difficult EECS 498 course, and you just got hired at your first game studio. Congratulations, okay? Now, you've been tasked, your first ever job, and you don't want to mess this up, okay? You've been tasked with creating a panda character, a panda class, okay? And it needs to do panda things. Your boss walks in and wants a panda, but you know that's not the last thing you're going to be asked for. You'll be asked to create additional things, maybe even other bears. So what do you do in order to get some code reuse ready? You might think about an inheritance hierarchy, okay? And how can you set it up? Here's one way. You're going to have a panda, but what is a panda? A panda is a bear. What's a bear? It's a mammal. What is a mammal? I would say like a living thing. Okay, and what is a living thing? At the root of our hierarchy is an object. Okay, there we are. There's our object. Well done. If you wrote this in C++, now C++ has an object. Not by default, but you added one. Amazing. Okay, anyway, so we have our is a hierarchy, and at every class in this chain, we kind of drop off and put little bits of functionality there. For instance, living entity might have a float that represents hunger. Now, anything that derives from living entity will have that hunger float, and that makes a lot of sense, okay? It's good code reuse, okay? Well, the next day, your boss walks in and you were correct. Your boss asks for an ice panda. Where will you put it in order to get the maximum code reuse and to avoid violating dry? You don't want to put the same functionality into multiple places in this tree. So where can we put ice panda?
Under panda.
That's right. We're going to put ice panda under panda. It is literally just a panda, but we're going to add some ice technology into this class, okay? Next, you get a request for the Lovecraftian panda, and the logic is much the same. You derive from panda, getting all the panda goodness, and you add some flying and some zombie skin technology, and there you go, your Lovecraftian panda. All right. Thus far, it's gone pretty well, but your boss comes in the next day and your life will never be the same. Why? Because your boss walks in the door and asks for the ice snake. And sleepless nights are now upon you. So, where are we going to put this thing? We would like to reuse that ice technology. Remember, we can't put the ice in multiple places in our tree. That's violating dry. We don't want to do that if we don't have to. We could try something like this. Look at this. How does this sound? Putting Ice Panda, right, as the parent of Ice Snake. What does this get you? Well, we have reused ice logic successfully, but you know what we've also done? We've put a bunch of snake logic into our panda, which makes no sense at all. It's going to be a mess, okay, at best.
Let's get some multiple inheritance going.
Just a few slides, okay? What else can we do here? What else can we do? What about creating a reptile category? Okay, well, yeah, let's do that. Let's get reptile going up here, okay? It's a living entity. It's not a mammal. Snake, ice snake, right? Or golden. Problem solved, right? No, not really, okay? This does have complications of its own as well. We are violating dry. We have ice technology duplicated in multiple locations in our inheritance tree, which isn't, there are some ways around this, but it's not ideal, okay? It's a bit frustrating. For those of you who have forgotten, I think I already talked about this in the past, but dry, don't repeat yourself. You want all sorts of information and tech in logic in your code base to have one source of truth, okay? This is the same thing as, accidentally making a copy of your actor class, of your actor instance, your actor struct. Suddenly, you have no idea where that actor is because one copy has x equals 5 and the other copy has x equals 1, okay? Anyway, let's keep going. What else can we do? Can we create an ice object? Well, we can, and we can put ice snake under it, but we are, once again, duplicating and violating dry. We've duplicated the ice logic, okay? So, what about normal snake or ice panda? What can we do? What happens if we want our ice panda to melt? During gameplay, we have an ice panda, we just want a normal panda. We want the ice panda to melt into that same panda, but now it's no longer icy. Can you adjust inheritance hierarchies? Can you change what your parent class is at runtime? Usually not. I haven't really seen a language that can do that. Have you?
In Java, you can.
Really? Oh, that's crazy. I think that's a pretty atypical feature. So, we are chasing our tail here. We seem to have come to a simple request, I just want an ice snake. But our current inheritance approach is just not giving us a good solution, all right? Now, this is very common, actually. Inheritance hierarchies, ISA hierarchies, have some significant flaws. So imagine that you have a bunch of images, a bunch of photos from a recent trip, okay? And you're trying to sort them to get your desktop to stop looking so messy. Hey, you want to see a really nice desktop? Let's go. Let's go. Is that nice or what? I even gave it a tasteful blur over some concept art from one of my games. This is cutscene art. This is a victory screen. All right. My other desktops at home don't look like that. All right. So everything is going super well. You're putting the boat photos into the boat folder, the car photos into the car folder until you see it. Uh-oh. This is your final photo. Uh-oh. What are you going to do? What are you going to do? You can't do anything. You have to compromise. At best, what you're going to do is you're going to throw this photo down one folder or the other, and you just hope you remember which one you chose when you want to look it up months later. It's a terrible solution, okay? Very, very nasty. Now, you might have heard of something called multiple inheritance. And this is the idea that, hey, actually, we want to inherit the properties of a snake and we want to inherit the properties of an ice object. And so why can't we just inherit from both of those and combine and compose those attributes? Okay? And, this is banned, this technique, multiple inheritance, is banned by a lot of the world's most popular languages. It is possible in languages like C++ and Python. But it's a bit of a red flag when a bunch of very successful languages say you aren't doing this, okay? No way, no how. And so I want to show you one issue that can happen. This is called the deadly diamond, okay? And I want you to ask yourself why this is deadly. Imagine you have a human class that has a sleep function. You have students who override sleep because students don't get much sleep at all. you have an instructor class that overrides sleep because they do get a lot more sleep. But then one day you find someone who is both a student and an instructor at the same time, which is what I was when I made this presentation in 2017. I was a master's student who took over 494. So wait, am I a student or am I a faculty member, right? And that was kind of an interesting time. And so a question for you, do I take the instructor's version of sleep or do I take the student's version of sleep? Which one do I take? In Python, I think you have a way to specify which one you want. I don't know if that's true in C++. You probably just get crazy compiler demons.
Yeah, C++, that's a compiler error. Java, C#, you can't do it.
Yeah. Python, it's like, yeah, I guess you can do anything in Python, I guess. This is called the Deadly Diamond, and it's nasty, okay? It's not very fun when your compiler blows up and gives you a billion incomprehensible errors. Right, we need a new approach, okay? Inheritance isn't getting it done for us. It's failing on really basic tasks, okay? So, composition, right? Have you ever heard the phrase, and this is one of my favorite phrases, actually. Have you ever heard the phrase, if it looks like a duck, if it quacks like a duck, if it walks like a duck, it's a duck, right? It's this notion that you're not defined by who you inherit from. You're defined by what you do, what traits you have, okay? This is not an is-a relationship, okay? Right? You are not, this is not a question of whether you are a duck. This is a question of whether you have the things that a duck has. So this is not an is-a relationship, this is a has-a relationship. Entities or actors or game objects are made up of components, little bits of logic that give them data and functionality. And if you've got the components you need, you can become anything you want, okay? And this is how it tends to be structured. You can see here that if you want composition, you need to use inheritance. In fact, you need to have polymorphism. Otherwise, components get really funky to implement. But basically, you have an entity or an actor class that is a container for components, a vector of components. This is what you're going to implement, okay? No joke, your actor.h is going to very quickly be getting things like this, okay? A vector or possibly an ordered dictionary, because components will have keys of components, okay? And each component is going to be a class that's going to have a start, update, and destroy or clean up function. So you might have a component, an ice component, that makes things look icy in the start function, and then cleans it up and clean up, right? You might have actors called panda or snake in your game, but it's going to basically just be a container for components. Now, we're going to finish this lecture next time, but I want to show you one final thing. And I think you might like this because this is showing you the future of your engine, okay? Earlier in the lecture, I actually showed more Homework 8 code than I probably should have. So here's another glimpse at Homework 8, okay? Beautiful, isn't it? When I run this engine, you're going to see a mini game that is the final test case in the entire course until Homework 9 gets created. Here it is. You see it? This is actually kind of fun. Have you seen this one before? No? This is a Box 2D powered physics engine platformer game. It is rollerball. You should take this course, build this, and then go do 494 with it, I think. So I can run around, and you see these yellow blocks? They're the bouncy blocks. Okay, they're a different type of actor. They are an actor template. And the thing about the bouncy blocks is that it doesn't just have a collider, a rigid body on it. It also has a component that will launch me if I touch it. It detects me touching it, and it just does this. Whee! Okay? Should make it play a sound effect, too. That'd be cool. I can come down here. I can bounce around, okay? The bouncy block, the yellow block, the red blocks, and this ball that I play as all have a rigid body component. That's the beauty about components. You can mix and match them, and once you've created a really awesome component, you can use it on any actor you want, and you can customize it, okay? For instance, all of these have a rigid body, but these have a static rigid body that cannot move, and this has a rigid body that's been configured to be dynamic and that can move. Question?
How does like a rigid body differ from like the colliders that we're doing now?
Well, colliders, often in a game engine, a collider is separate from a rigid body. A rigid body gives an actor velocity, gravity, right? Momentum, angular velocity, friction, drag, a bunch of physical properties. But a collider actually tells the physics engine what is the shape of my physical object. So in an engine like Unity, the red blocks and the ball would both have a rigid body, but the red block would have a box collider and the ball would have a sphere collider, okay? Because boxes and spheres, they interact with the physical world in a much different way, right? In your homework 8, there's just going to be a rigid body component. There are no colliders, and you will configure on the rigid body itself whether it has a collider and what shape it will be, okay? And that's how it's going to go. Anyway, I'm running around. We've got logic for timing. Okay, I can hit things and trigger the ending, right? This is kind of a deluxe. This is like an actual game, okay? Now, how does this work? Let's look under the hood, okay? And then we'll end the course or semester or lecture, okay? You know how much sleep I had last night? Oh my gosh. I just booked my first trip to Japan ever, and I was up till about 4 a.m. doing it. And now I have to grind Japanese language because I haven't really practiced it since high school. So, yeah, we'll see how that goes. Anyway, what is happening here? Well, if you go into the Homework 8 solution and go into the resources folder, the resources folder is our test case, right? But it's literally a game in itself. All the game is in here. The engine is outside, but the resources folder is the game, okay? When we go to the game.config, we can see what file do we launch first. Well, the first scene we load is named basic. So let's go into scenes and look at basic for a second. The basic scene is truly basic, okay? It has an array of actors just like your scenes do. Each actor is an object. We have our first actor, its name is camera, and it has one component, okay? It has one component and of type camera manager. Nothing configured on the component, no variables changed, that's it. We then have a game manager component, and it just has a component of type game manager. Very simple. And then a HUD actor, a game manager actor with a game manager component, a HUD actor with a HUD component, okay, right here. Now you can look into these and see how they work because every one of these components, this is a type. They exist as a Lua script in the component types folder. So you can go to camera, and I'll open up camera really quick, camera manager, and look at what camera does. You may not be able to read Lua yet, but you could probably figure out what it's doing, okay? Camera manager is a component that has two variables, ease factor to control how quickly it chases around the ball. So we could change how, do you want to? Hold on, wait a second. Okay, when I go back and forth, you see how the camera kind of slowly follows, but pretty tightly, right? It kind of slightly trails the ball as it moves, right? Well, here's what we're going to do right now. I'm going to change this to 0.1. Ease factor is going to be way less, so we're very slow following the object. But I'm not going to change it here in the source code itself. I'm going to change it here, okay? I'm going to override a property called ease factor. I'm going to make it 0.001. Okay? This is like several orders of magnitude slower. And I'm going to relaunch the game. Oh! It's slowly following the ball. You see this? How sluggish it is? It's slowly following the ball. Okay? So, right? And notice I made that change without changing any code at all. That's the power of composition, okay? Anyway, all this stuff going on, the game manager.lua has the actual map in it. It reads this map file, and then it says, oh, there's a 2 here in the bottom left corner. That's the player spawned in, okay? When this actor loads in, go ahead and look through that array and spawn things, okay? It spawns players, it spawns kinematic boxes, it spawns bouncy boxes, and the victory boxes. What are these things? Let's look into the prefabs, or the actor templates. Here's our player, okay? The player has these components on it, customized to be like this, okay? It has a sprite renderer component, customized to use the circle, but you know what else uses the sprite renderer component? The kinematic box uses the sprite renderer component, but it gets told to use a different sprite, okay? The victory box uses the sprite renderer component, the same component, but just with some different variables, okay? Box 4 instead of box 2, okay? And you can look at all these component types and have a great time. The sprite render, yeah, just kind of grabs the rigid body component that the object has. It then uses that component, self.rb, to draw certain positions, okay, and rotations, and we draw whatever sprite we've been configured with, which is always a variable, right? And then those sprites are in the images folder, right in here, right? Here you can see them. So hopefully this is, I know it's been very fast, and you don't have to understand what's going on here. But I want you to start thinking right away, how would you structure your game engine code base to kind of say, oh, I've got some actors, and each actor has some components, and those components have an ordering, and those components all have their own functions on them, okay, that need to be called at a certain time. Start when we begin, update every frame, and on destroy when they get taken off, right? How would you implement a function like get component? How do you implement a function like add component or destroy component, which alters an actor's components at runtime? Like, all of this is why Homework 7 is so difficult. But if you understand components and what they give you, then you have a big head start, okay? And you can start experimenting pretty quickly. In any case, if you really want access to Homework 7 early, like you finished Homework 6, like, you can find it. I'm not going to make it easy for you, but you can find it, especially if you look at the syllabus. But what I would do, my recommendation, everyone, think about components. We're going to finish talking about them on Wednesday, and we'll talk about some other stuff on Wednesday. And take the next week, if you finished Homework 6, to relax, okay? To freshen yourself up. Okay, get ready to put one good week of Homework 7 in, and then we'll take our 2-week break for spring break, or our 1-week break, and then we'll come back and knock the rest of these out, okay? I think Homework 6 remains the hardest homework in the entire course, but I think you're really going to like Homework 7 and 8, and hopefully 9, okay? So anyway, everyone, that's about it for today. I'm going to be here from 6 to 8 o'clock, okay? So 2 hours of office hours. Please let me know if you have any questions or comments or anything like that. Thank you for joining us. It's really good to see you. This is my most packed class, but it's not my largest class by enrollment, so I really appreciate you being here. Yeah, I'll see you next time. Take care, everyone. Bye-bye. Everyone online, I will see you later, okay? Take care. Have a good night. Bye-bye.